In this video, I'm going to give a walkthrough of this collab, which is custom optimizer training loop, WAN, DB, and submission. Um, in the first cell, okay, I'll just go ahead and run the first cell. Before that, I'll change the runtime. Yeah. So in the first code cell, I install the WAN DB library, which stands for weights and biases. It is used later in the notebook for experiment tracking, logging metrics, and saving model checkpoints. Next, I would run this cell. Here, I import all the required libraries such as NumPy, Pandas, Matplot library, TensorFlow, weights and biases. Then I set the random seed for TensorFlow, NumPy and Python so the results are reproducible. I also define global settings like batch size, a number of classes, then print the TensorFlow. Um yeah, and also weights and biases version to confirm the environment setup. Next, in this cell, I load the fashion MNIST dataset and normalize the pixel values to range from 0 to 1. Then I create the training, validation, and test splits and keep smaller subsets so the notebook runs faster. Yeah, these are all the three set of splits: ID, train, valid, and test, and their respective values. Next is helper function. This cell defines the main helper function used in this notebook. First, I define a simple multi-layer perceptron model for classification. Then I define the helper um, functions for plotting, training, history, evaluating a model, then summarizing experiment results and comparing multiple runs in a table. Next, here I train the baseline model using the standard Keras model.fit. Workflow: the model uses the Adam optimizer, sparse categorical cross entropy loss, and accuracy as the metric. Then I evaluate it to test set, store the training history in a data frame, and plot the learning curves. This acts as a reference workflow for comparison with the custom training loop. We can see here. Next, I would run this. In this cell, I define a custom optimizer called simple moment optimizer. Then I have also in this cell, we totally can see how an optimizer can be implemented from scratch instead of using a built-in Keras optimizer. Then here I define the custom training loop using um, TensorFlow's gradient tape, and I also compute the validation metrics after each epoch, and optionally write the tensor board blocks and optionally log results to weights and biases. So this cell gives fully control over to the training processing instead of relying on model.fit. Next, in this cell, I build a fresh MLP model and train it using the custom train loop I defined earlier. I also provide a denser board log directory can be so that epoch wise training and validation metric can be stored. Yeah, these are the graphs and the table. Next, here, like I would launch the Tensor board, which is more interactive and which helps to visualize better and visualize the metric clock during the custom training loop, such as training loss, validation loss, training accuracy, and validation accuracy. Next, I would run these. Here, I initialize the weights and biases, run in offline mode, and log experiment configuration details such as epochs, batch size, model type, and dataset. Then I train another MLP model using the same custom training loop, but this time using the same custom training loop, but this time using with WB logging enable. At the end, I log a final test loss and test accuracy and finish the run. Right. Here is the whole table with epoch, train loss, value loss, and train accuracy and their respective values. I would next go ahead and run this. So in this cell, um, okay, sorry, Keras fit, right? Okay, in this cell, I run one more experiment using the standard Keras fit workflow, but this time with the W and B callbacks. I also evaluate the train model on the test set and store the training history in data frame. This shows how W and B can also integrate easily with built-in Keras training API. Next, in the final comparison table, I compare all the training workflows in one summary table, which we can see here. And then I would run the final bar chart. In the final code cell, then we can see the visualization comparison across the workflow using a bar chart. This gives a clear final summary of how the standard training API, custom loop, and WB integrated workflow perform related to each other. So, overall, in this notebook, it compares multiple deep learning training workflows, and we have seen through each steps that are involved in this whole process. And that's it with this notebook collab walkthrough. Thank you.